welcome to the BKR chemistry classes. Last video we have seen how to arrive at R bar S configuration, and to continue that I'm going to solve few jam problems in this particular video. Jam 2015 question they've asked for 2s3R configuration of 2 amino 3 hydroxybutanoic acid. So let us see how to arrive at these configuration. So these are compounds which contains two chiral carbon. They contain two chiral carbon. So it is very easy actually. So I have the carbon here. So this is carbon 1, 2, 3, 4. This particular carbon is a chiral carbon and this is also a chiral carbon. Carbon 1 and 4 are not chiral. They're asking for the configuration of second carbon and the third carbon. So how to arrive at it? So first you have to do it one by one. So take the first carbon, this carbon. So this particular carbon has nitrogen, hydrogen, and the carbon below, and you have a carboxylic acid carbon. So you have four different atoms. So it is a chiral carbon. So now the atomic number of these atoms has to be given priority. So nitrogen gets the first priority. Then you have carboxylic acid carbon and this carbon. So this carbon, this particular carbon, the third carbon has hydrogen, oxygen, and carbon attached to it. Whereas the carboxylic acid carbon, we already know it has three oxygen. So already I've told you. So if I have a C double bond O, C double bond O corresponds to carbon attached to two oxygen, and you have one more oxygen here. Therefore, you have carbon attached to three oxygen. So C double bond OH corresponds to carbon attached to three oxygen atoms. So here, the C with three oxygen takes a higher priority compared to a carbon with one hydrogen, oxygen, and carbon. So this carbon gets a second priority. The carbon below gets the third priority, and hydrogen gets the fourth priority. Okay. So now, if I draw a semicircle from one to two to three, it traverses a anti-clockwise path. Therefore, I'll say it's an S configuration. But remember, whenever you have a least priority group in the horizontal position, it is a near group. So we cannot label R bar as configuration by keeping the least priority in the horizontal position or near position. It should be far away from us. So strike out the configuration and write the next configuration, which is the correct one. So R is the configuration for the second carbon. So but here they're going 2S, but it's 2R. So this option A is wrong. Option A is a wrong option. Okay. So now you can see that the compound A and C, they are mirror images of each other. So we should know that if I have an isomer which is A, B, C, D, if the mirror image is there, the mirror image will be written as A, B, C, D. If it is A, B, C, it is R configuration. The mirror image will be having A, B, C, which will be S configuration. So always the enantiomers will be having opposite configurations. So a compound and its mirror image will have opposite configuration. Okay, so if I have one enantiomer as R configuration, its mirror image, the other enantiomer will have S configuration. So A and C are enantiomers, A and C are enantiomers. So A is the enantiomer of C, they are mirror images. So if I am having R configuration for this particular carbon, C1 carbon, this carbon should have S configuration. So it is 2S. So if I know the configuration of the third carbon, then I can straight away get to the answer. Okay. C3 carbon is attached to hydrogen, oxygen, carbon, and the carbon containing the nitrogen, hydrogen, and further one more carbon. So obviously oxygen will take the first priority. And now you have carbon containing three hydrogens, and this carbon contains nitrogen, carbon, and hydrogen. Obviously, nitrogen takes the upper hand, carbon has takes the upper hand. So compared to three hydrogen, this carbon has higher priority. So one, two, three, and four. So now traverse a semicircle. So when I traverse a semicircle from 1 to 2 to 3, It takes a clockwise rotation. Clockwise rotation means it's R configuration. But we have already told that keeping the H in the horizontal position, you should not assign the configuration. If you have assigned, just strike it off and write the S configuration. So we are not going to do all rearrangements to bring the H to the vertical position. Just simply give the configuration and strike out and give the next configuration the right configuration. So this particular compound has the configuration of 2R 3S. 2R 3S. But what is asked? 2S 3R. Now our job has become very simple. So as I told, compound A and compound C are mirror images of each other. So if compound A is 2R 3S, the compound C will be 2S 3R. So if A is 2R 3S, the C is a mirror image of A. So C will be 2S 3R, and that is what has been asked. So they asked for 2S 3R 2 amino 3 hydroxy. So the answer is option C. Okay, for you people, let me do the arriving at configuration for option B. Let us see immediately. Okay, this carbon is chiral carbon. So nitrogen 1, carboxylic acid will be second, and this carbon will be third, and hydrogen will be fourth. So 1, 2, 3. 1, 2, 3, it's traveling clockwise, which is R configuration. But since H is in the horizontal position, try strike out R, give S as the answer. Now look at the below carbon. So carbon below, we have this carbon 1. The carbon containing nitrogen gets the second, and this carbon will be third and fourth. So 1, 2, 3. Again, it's traveling a clockwise direction, so it should be R, but strike out R because H is in the horizontal position, therefore you get S. So this compound has 2S, 3S. So obviously here you have two different configurations, so this is the wrong option. Now let us check the option D. Now you can, as you can see, the compound B and D are mirror images. So if B is 2S, 3S, D should be obviously 2R, 3R. Okay, so always the enantiomers will take the opposite configuration. Keep that in mind. So you need not work out the configuration for all the compounds. Simply by knowing the concept of mirror image, you can arrive at the answer. So option B is wrong. Option D is wrong. So answer is option C. The next question is JAM 2018 question. They've asked for number of compounds which have S configuration. So they've given five options, and here you have to write numerals. So one, two, three, four, five. So the first compound, you can see this is the far least priority group, hydrogen. So now the carbon, chiral carbon has bromine. Bromine gets the first priority, and carbon with three hydrogens. Carbon with three hydrogens. Whereas this carbon has ethyl group has carbon with two hydrogen and one carbon. So obviously, the C ethyl gets the second priority, methyl gets the third priority. Therefore, one, two, three. I'm going to do the assignment from this direction, anti-clockwise rotation, and therefore it is S configuration. So this first compound is S configuration. Second compound, we know this very clearly. So one, two, three, four. So one, two, three. Again, it takes S configuration, but we have seen that H is least priority in the horizontal position, therefore it is wrong. So R is the answer. So second compound is having R configuration. Third compound is an allenes. Allenes. So while assigning the configuration for allenes, see you can see that you have to take this carbon and this carbon. Okay. So if I'm going to look from this side, so the view is very important. If I'm going to view from this particular side, I have to take these groups as the near group. So I have to put them as bold. So they are vertical, they are in vertical position. So I have to put a thick line. So when I put a thick line, that shows that this is the position I'm viewing at. So they become the first viewpoint view. So they are the first point of view. So since I'm viewing from this particular position, so they become the near group for me. Okay, and they'll be given priority first. So it is not like the priority given for a chiral carbon for different substrate. It is slightly different. And now these group becomes far away. So it will be given in the form of thin lines. So thick line shows that where I'm going to view, from where this position I'm going to view, those groups becomes the thick line groups, they are near groups, and the one which are away from my view, they become the far groups. So they'll put as a thin line. So here the priority is not that the near group, far group, not like that. Okay, so first I've got the near groups which are given the thick lines. Now put them. So hydrogen and CH3, hydrogen and CH3. So I'm standing here looking at this molecule. So when I look at this molecule, this becomes the left group and this becomes the right group. So left group is CH3 and the right group is hydrogen. Now, then from the position I'm viewing, those groups should be labeled first. They should be given priority first. So carbon first priority and hydrogen second priority. So it is not that all the four groups 1, 2, 3, 4. No. So the first near groups has to be labeled 1 and 2. Then you'll go with the back groups, the away groups. Now from the away groups, you will give 3 and 4. So CH3 gets the third priority and H gets the fourth priority. So now assign the configuration 1, 2, 3. 1, 2, 3. So the configuration is, it is rotating anti-clockwise, therefore it is S configuration. It is S configuration. So this is also having S configuration. So don't confuse with the regular nomenclature. These are slightly different. So you have near groups, which is the position which I'm viewing. Okay, let me do it for you once again. What I'm going to do is I'm going to view from the other side. So near groups are in horizontal line. They are in the horizontal line because I'm viewing from here. They are on horizontal. So now since I'm viewing from this position, my eyes are here. My eyes are here. So since I'm viewing from here, now CH3 becomes right hand side and hydrogen becomes left hand side. And in the vertical, I have hydrogen above and CH3 below. Hydrogen above and CH3 below. As I told, I'm viewing from this side, I'm viewing from this side. So they become the near group for me. So I should label them first, give priority them first. So CH3 first priority, hydrogen second priority, and then label the priority of the far group. So these vertical groups. So this becomes third priority and fourth priority. So 1, 2, 3. Again, it is taking the anti-clockwise direction. So it is S. So as we have seen, I view from either side. Either side, I'm getting the S configuration. So this compound is also S. So this compound is R. This compound is S. Now look into the fourth compound. So fourth compound, I'm going to assign priority from this side. Okay. So I have here nitrile C triple bond N. C triple bond N, which means carbon is attached to three nitrogens. It is attached to three nitrogen. And CH3, carbon is attached to three hydrogen. And CH2 and H2, carbon is attached to hydrogen, hydrogen, and nitrogen. So now we know that the three nitrogen will take the upper hand than one nitrogen than the three hydrogen. So one, second priority, and third priority, and hydrogen will be fourth priority. So since I'm viewing from this side, I'm going to assign priority. But as I told, for a Fisher form, you should try to assign priority, keeping the least priority away from you. It should be given priority, keeping the H away from you. Okay. So just imagine you are standing behind this particular board and assigning. Okay. So when you do that, so just imagine I'm rotating from standing here somewhere. So it goes 1, 2, and 3. Okay, so you have to imagine that. So you have to imagine that 1, 2, 3. It is taking an S direction. Okay, so it's configuration. Okay, suppose you feel that you are not able to imagine from the back of the board. Okay, let us look from the front. I'm going to look from this position, from here, from the front of the board. So now 1, 2, 3. 1, 2, 3 takes a clockwise rotation. It takes a clockwise rotation. So you'll get an R configuration. But as I've told, the least priority 4 group is in near. I am viewing the molecule, keeping the least priority near to me. So whatever I get is a wrong configuration. So S is the answer. So this molecule also has S configuration. So last molecule again has a chiral carbon. So for this chiral carbon, you have four substituent hydrogen, CH3, and here you have a CH2 followed by a CH, and here you have a CH2 followed by CH2. So there are four different substituent. So now, among these four substituents, this carbon has three hydrogens, whereas this carbon has two hydrogen and one carbon, and this carbon also has two hydrogen and one carbon. So the first point of difference, this is ruled out. So this is not coming under one or two priority. So among these two options, I have a confusion because this also has hydrogen, hydrogen, carbon. This also has hydrogen, hydrogen, carbon. So when I walk further, I see that this particular carbon is CH, which is multiply bonded to a CH carbon. Whereas this is a CH2. CH2 bonded to a CH. So this carbon has hydrogen, hydrogen, carbon, whereas this carbon has hydrogen, carbon, carbon, because it is C double bond C. So already I've mentioned. So whenever you have a double bond, that means the carbon is attached to equivalent atoms by two single bonds. So now you can see you have HHC here and you have HCC here. So obviously two carbon will take higher priority. Therefore, this particular carbon has first priority. This carbon gets second priority. CH3 get third priority, and hydrogen fourth priority. So as we have seen, this is first priority, second priority, third priority, and fourth priority. So 1 to 2 to 3, it takes a clockwise rotation. So we expect our configuration. But see here, you have the least priority hydrogen. It's towards us. It is near. It is towards us. So whatever configuration you're given is a wrong configuration because while assigning configuration, the least priority should be away from us. So R is the wrong answer. S is the correct answer. So compound 1 is S configuration, compound 2 is R, compound 3 is S, compound 4 is S, compound 5 is S. So among the 5 compounds, 4 compounds have S configuration, therefore answer is 4. Hope you have understood this video very clearly. If you have any doubts, you can post that in the comment section. If you want me to cover any other topic, that can also be posted in the comment section. To watch videos of similar kind, kindly like, share and subscribe the channel. Thank you so much.